This is another important question that was the answer is given as all, and one of you asked me when we do the calculation, I get an answer from this one, but why this is given as all? So then I explain to you what is actually happening here. So we will discuss this one. So there is a buffer solution that can be prepared by mixing a weak acid and a strong base. So you know, normally we mix a weak acid like HA with a strong base like NaOH, and there will be this salt NaA that is forming plus water. Okay, so when you have this weak acid as well as the salt of the acid, so this makes a buffer solution. Okay, then they're asking the ratio of the concentration of the acid to base in order to prepare the buffer solution at pH 6. So if you remember about the Henderson equation for a buffer solution, it is pH is equal to pKa plus log salt concentration over acid concentration. Okay, so pH is given, that is 6. pKa you have to calculate using Ka. So pKa is equal to, right, minus log 4 into 10 to the power minus 7. So 10 to the power minus 7 into minus log base 10 will make this as 7 minus log 4. Okay, so there will be something like 6 point something. So I will just check that for the moment. uh, so log 4 is 0.6. So this is 0.6. So my factor becomes 6.4. Okay, so pKa is 6.4 plus log the salt over acid. But here they have asked about acid over base. So first we'll consider this one. So you can imagine the values here, minus 0.4 is equal to log salt concentration over acid concentration. So if you take the antilog here and you get the acid over salt, you will see the ratio is 5:2. Okay, so this is a straightforward calculation, because when you get the pH and pKa, then you get the minus value here, then you get the antilog. You will see the salt over acid will be 2:5. So the acid over salt is 5:2. Okay, so this is a straightforward calculation. So according to that, the answer is fifth one, which is 5:2. Okay, but why this is all? Because when you try to make a buffer solution, for an example, if I mix this is in 1:1 concentration, still I will end up getting a pH 6 buffer solution. So as these ratios, because here they have mentioned only the concentration ratio, which we get 5:2. Okay, but in this equation, when you put this concentration over acid, salt concentration over acid concentration, this concentration comes by multiplying concentration of the salt that is formed, and then you divide it by the final volume over concentration of the acid that is remaining over final volume. Okay, so this is formed concentration for an example, right? When you mix these two. Okay, but you have to understand here, when you add HA and when you combine it with NaOH, there will be some amount of NaA that is forming, and finally there will be these two that is remaining in the solution. There is no NaOH because we add a little amount of NaOH. That is when there will be excess HA and little bit of NaA that is formed, which is equal to the amount of NaOH that is reacted. For an example, I will stop sharing and use the board to explain this one. Okay, so let's say we have HA plus NaOH, which is going to give NaA plus water, right? So I am going to use 0.1 m HA 100 cubic centimeter. And I'm going to use 0.1 m NaOH 10 cubic centimeter for this reaction to happen. Okay, so at the end of the day, what is going to happen? Here there will be 10 into 10 to the power minus 3 moles, and here there will be 1 into 10 to the power minus 3 moles. So at the end of the reaction, so this will be 10 into 10 to the power minus 3 moles minus 1 into 10 to the power minus 3 moles, where sodium NaOH is going to react completely because this is the limiting reagent here. So there will be no NaOH at the end. So that is why this will be 1 into 10 to the power minus 3 minus 1 into 10 to the power minus 3. So this is cancelling out. So this will be 10 to the power minus 3. This is 1 into 10 to the power minus 3. So there is 9 into 10 to the power minus 3 moles at the end. So there is no. So same amount that is reacted as NaOH, same amount that is going to form here. So this will be 1 into 10 to the power minus 3 mole. So you can imagine how much you put, how much the salt is formed. So according to this equation, pH is equal to pKa log salt over acid concentration, right? So we need to obtain a pH of 6. This is 6.4 plus log. Now, what is the salt concentration? So the salt concentration here is 1 into 10 to the power minus 3 moles over the volume. So what is the volume? The volume is, I am mixing here 10 cubic centimeter and 100 cubic centimeter. So the total volume is 110. And what is the acid concentration? This is 9 into 10 to the power minus 3 moles over the total volume is 110 into 10 to the power minus 3 decimeter for an example. Okay. So we have 6.4 as the pKa, and we have a solution to find the pH. We don't know. Okay. But if we want to make a solution of pH 6 by using the same equation, all these, we can change this volume in order to make the same pH 6 solution. For an example, if I take my total volume of the system to be 100 cubic centimeter, I will take the volume of HA that is going to be present is V. Then my salt volume will be 100 minus V. Okay, so if I put that here, my salt concentration will be, my salt concentration in this equation will be the concentration of the salt, which is 0.1 m still, because 0.1 m amount will be formed, or either you use NaA, which is 0.1 m, times 100 minus V, which is the amount of volume that is going to put, and the total volume will be 100, over acid concentration is still 0.1 m, the volume of acid will be V over 100. So according to this, when you do this calculation, you will have a value for volume of the acid VHA as well as volume of the base Na, which you should understand, even though this is my volume of the salt, this is 100 minus V, this is the total volume that I am expecting to make. So what I am telling you here is, check the concentration that I have used here, 0.1 m, 0.1 m. So when you mix it, it will be 0.1 divided by 2, which is 0.05. In fact, if you think about the same volume, but we don't know what is the volume. So initially I use as 0.1. So if I use this as 0.1 m, the salt, so I am not going to mix with this NaOH and everything. So I have this solution where I have 0.1 m HA and 0.1 m NaA. My total volume should be 100 cubic centimeter. Okay, and I do this calculation. I realize I have a volume for HA and I have volume for NaA that I can mix in order to make this solution pH 6, a buffer of pH 6, which you should understand. The concentration that I have used here is 0.1 m and 0.1 m. The ratio of acid to salt is 1:1. Okay. So if you use 1:1, you will have one volume for HA, one volume for NaA. In the same way, what you can do here is, if you change this as 0.2, which is now 2:1, the only thing that is going to change here is this V. Because when you put 0.2 and 0.1, and when you do the calculation here, by putting 0.2 and 0.1, what is going to happen? This volume that you are going to get after the calculation is going to change. So what you have to understand, from the calculation that they have given, when you do this calculation and see, you will get an answer of 5:2. But 5:2 is just the concentration ratio, right? But you can change the volume by changing even the concentration ratio to get the final concentration, which gives up a solution that pH is 6. If you use 1:1 concentration, you will have one different volumes, V1 for this, V2 for this. If you change the concentration ratio for 2:1, still you are going to get V3 and V4, but different volume for different concentration. So according to this explanation, what you have to understand for this particular question, when you do the calculation, you will end up with this one. Okay, but this is okay, right? If you mix same volume, but you can change the volume to make the concentrations indifferent. For an example, here I did the calculation. Here I showed the calculation where we use the concentrations are same. This is this one. So when you do the calculation for this one, and you see whether I am getting a volume of the acid and the volume of the salt that I want to mix, you will still get a result for that. So this one is also correct. even this one, all these can be used, because when you use these different concentration ratios, the only thing that is going to differ is the volume. Okay, for an example, if you think 5:2, the volume of the salt can be lower than the volume of the acid. If you use the reverse, here 2:5, the volume of the salt can be lower than volume of the acid, because concentration of salt is higher here. So here the concentration of acid is higher, so the volume will be lower. Here the concentration of acid is lower, the volume will be higher. So anyway, you have to understand all these values can be used in order to make the pH 6 buffer. That is why they have given here the answer as all, because you can use any of these. Okay, so try to understand this concept. This is important to understand, right?